Hi everyone, this video is an exercise 11I question 1 which is on trapezium rule. So we are given this sketch of y is equal to root 1 plus tan x, and in part A we want to complete the table with the values of y corresponding to x is equal to pi over 12 and pi over 4. Right, so first of all, this is the formula in red, the formula for the trapezium rule, which will be given to you in the formula booklet. And it's a very useful method because it's a numerical method, in fact, and we use trapezium rule or many other numerical methods when the integral is very complicated that can't be solved analytically. And in fact, almost the vast majority of the integrals in real life problems are solved numerically. We can't solve them analytically. Anyway, so here, so in part A, we just need to substitute each of these values basically into y, and then just give and then find the answer. So when x is pi by 12, then we get 1.126. Then when it's pi by 4, we get 1.414. So 42. And now now that we have these values, then in part B, we can use the trapezium rule to find the integral. So first of all, we always find the value of h. So h is equal to the upper bound minus lower bound divided by n. N is just the number of strips or the number of intervals. So in this case, we have basically the upper bound is pi by 3 from the question, and then the lower bound is pi by 6. And remember that the number of strips here is only 2, because essentially the region is from, if you imagine the x-axis, so you have 0, you have pi by 6, and you have pi by 3. So basically you have essentially 2 intervals or 2 strips. So that's why n is just 2, and therefore the answer is pi by 6. Then we just use this to substitute into the formula that I is approximately equal to basically so it's actually half h. Here is not very clear, so outside we have half h, so here is basically for the inside we'll have half times h, so h is pi by 6 basically. And now inside y0, so the value of y0 in this case is just 1, so the first y value essentially, and then 2 times the approximated y values that we found. So we found the value of y2, as well as, well, actually in this case, so we only want the values for that. Basically these are the x values, so we want the corresponding y values. But remember that we always write down the value of the first and the last x coordinate just outside of the bracket. So because we'll have this sort of bracket that so we write down y0, which means the first y value, and then the last y value outside of the bracket, and then everything in between is going to be inside the bracket at 2 times that. So in this case the first y value is 1 because that corresponds to 0, and then the y value that corresponds to pi by 3 is 1.6, so it's 1.6529. And now everything in between goes inside a bracket. So in this case we only have one more value, which corresponds to pi by 6, and that's this one, which is 1.2559. And yeah, so we now just solve this, and the answer is 1.352 to 4 significant figures. Now for part B, it just the same thing really. We just have some additional terms, and we just need to make some changes. So first of all, in terms of the value of h now, the upper bound in this case is pi by 3, and the lower bound is 0, and the number of strips is always 1 minus the number of x values, total x values that you have. So in this case you'll have 4 strips, so it becomes pi by 3 minus 0 over 4, which is pi by 12, and then I is approximately equal to, so again h times by half, and now inside again we just write down the first y value, so 0 corresponds to 1, and also the last one is 1.65, so we'll have 1 plus, and then also the last one is 1.6529, and now everything in between is going to be inside a bracket. So remember that in between we have three different x values, so we'll have three different y's. So in this case, we just basically have all of these y values here for pi by 12 to pi by 4. So we'll have 1.26 plus 1.2559, and finally 1.4142. Yeah, and this gives us 1.341.